So, on a daily basis, you're going to use this on your system, and any two transactions on different servers can write to the same system. So what happens is these don't intersect. We are doing simultaneous write. They don't intersect, and on that case they intersect. So you have to be aware of that. That in the middle of your process, you will have transactions that will abort because they're concurrently writing in the same data in different nodes. That is achieved, like I said before, by certification. So, like I said, you need to configure a full UUID as a group name, because since we only support GTIDs, and GTIDs are a big base for the certification process, the GTID that the transaction will have is the GTID of the group name. So there won't be a GTID for this one, and for that one, and for that one. You will have a full, if you go to this one and this one, they will have the exact same GTID, which is not a one generated by the server and for the server, but the one for the group. In terms of management, we only use PS tables, so you can only see information from group application. You don't see it from the regular commands. So we added tables to check the lag between the connection status between all nodes, the information that you have for the members that you have, so this one member, more members, and the more geeky stuff to know how many transactions have been dropped, how many transactions are holding up to be approved, and everything else. So, in terms of conclusion, it's cloud friendly, so you can deploy things like take this node, take out that node, put that node again. We revamped server core. We added hooks to server core to put plugins in and out. The specific thing that you talked about InnoDB was because of we need to abort transactions, and InnoDB didn't expose that functionality. Now it does, so we can go to InnoDB and say this transaction has more priority than that, abort that one. And it supports everything that is, let's say, modern in MySQL. So GTID, row-based replication, and performance schema tables. And like I said before, again, it's self-healing. So there's no admin overhead. And it has lots of uses in scenario, although you can still use the node for regular replication. We've been doing constant lab releases every 3 months. So we like to hear your feedback and your experiences on this. So I'll be around the whole day. I can take your notes and hear your thoughts about it. And with the new MySQL infrastructure, so group replication and MySQL router, in order to group the clients to the correct nodes that you want to write data to. In terms of releases, so the major 2 releases were quite a milestones because we had the new communication engine, and that introduces some more platforms. And in the last release, we have Windows support. So it's interesting that it gave some work to have it working, but it's cool. So the packages are on labs, and we blog a lot about this. So when we have new releases, we do lots of blogs. So throw questions at me. Can I start with that? You.
So when a node leaves the group, it rejects any attempts for inserts, updates, etc. Otherwise, what would be my indication as a user, or as a, I went through the redistribution of queries on other servers? How do I know to ignore that particular server?
You leave. Yeah, there's a difference if you crash or if you leave voluntarily. Okay, if you leave voluntarily, you will be able to use that node as any other MySQL node. So if you leave involuntarily, you won't be able to do any queries. So
say this server has a problem communicating with the rest of the group, I don't know. Does that mean he will stop rejecting my queries? And is there a select show what's your status that will
yes, with PS tables.
Okay.
Okay. It will report itself as offline.
The writes will fail, so.
To site?
about transactions.
20.
Here.
Yeah.
You said that in the second case that one of transaction will be rejected.
Mm-hmm.
What is performance penalty for this synchronization?
Yeah, we haven't. I have to take that offline with him. I think he has better knowledge from me.
Okay.
Yeah.
So I just want to compare it with like Galera, it's all masters should commit it. Same.
Okay, I will take that offline with him.
Okay.
So I can have you understand. Yes.
What happens, like in the case of causation, like I use a base model, what happens then if there's 6 nodes, I use 3?
I can say that we have work on progress on that. Currently, being honest, it works. If you have 6 and you go 3 plus 3, the remaining 3, both group will block. So you won't be able to do it. But we're thinking. Like that.
I wonder when a node is recovering, does it need like a donor node, and is that donor node is like in read-only state or something like that?
No. You can. There's a catch-up process. So the donor node will donate until the view ID, but the node that's entering is receiving all the transactions. So what will happen is he will apply all the transactions from that leg that he receives, and then he applies the rest. So the group keeps on working even if one node is entering. So then we have 2 caches, the one that he's receiving, and then he applies the rest of it.
Including the donor node is still working then?
The donor node is still working. The whole group is still working, and the new node is already receiving the new transactions. Then it will catch up. Yes?
What happens if you have one big alter on a node? Will co-pastor block for this node? For this alter?
No, we don't support online VDR.
So you don't have.
Okay, that's the point. We don't support online VDR. That's one of the things, the limitation. I try to avoid the limitation, not on purpose, but to have room for this type of questions. But yes, we don't support online VDR. Yes?
So I have 2 questions actually. One of them is I understand that when transactions are rejected, they are always rejected online. There's no way that the plugin is going to receive a commit and then it's going to be rejected afterwards.
No.
Okay.
So if it works, it works.
If it works, it works, and
Yes.
so you get the promise that if we eventually commit everywhere.
Yes.
Okay. And the other one is how big the replication groups have been tested. And is there a performance penalty for having groups of hundreds or thousands?
Okay. The issue that you have there currently is XCOM, the communication engine. So it's Paxos, it agrees, it needs an agreement to everyone. So at most it will degrade with the number of groups linearly. At most. Because it has a full connection and it's a consensus protocol, everyone enters in the consensus routes. So everyone says okay to the transaction. That's how it's implemented. Yes.
I didn't understand whether it's atomic or eventual consistency.
So the thing is, it's not atomic. It's even. So the nodes. Let me explain the process. It's better. So the nodes certify. So they say you can commit to the one that's committing. Okay, because he also receives that exact message on the exact order. Between that point and the rest, they may fail. And between those 2 points, you may try and read things from that node, and it's still not committed.
And what kind of latency do you see between servers inside the network? Is that the same?
It's quick. It's but you are, no, I say it's quick, you are asking the latency between committing a transaction, saying okay to that transaction, and actually committing it, or the distribution of the transaction. The distribution of the transaction, I think. Because the reason I'm thinking is because since I work on the GCS layer, I work underneath. I always have the problem because I don't. Typically, I'm on the world that we think on messages and not on transactions.
You're running out of time.
Did you show me the timing?
Ran out.
It was entertaining. So thank you for attending.
Tell me we'll be at the
Yes.